This video is going to consider some of the key understandings in relation to the core concepts of chemistry in the bonding and structure unit. As a reminder, here are the 7 core concepts in chemistry. And of these 7, I think that probably 4 of them are really important for understanding bonding and structure. So let's have a look at particles, charge, electrostatic forces and potential energy, and identify some of the key understandings related to them. Let's start with particles. The first type of particles we need to know about in order to understand the basis of bonding and structure are protons and electrons. And these are 2 of the 3 subatomic particles found in atoms. Of course, atoms themselves can also be treated as particles. And atoms may combine via covalent bonding to form molecules which can also be treated as particles. Of course, if atoms were to lose or gain electrons, they would form ions. And when modelling bonding and structure, we can also treat them as particles. If you're unfamiliar with any of these terms, you may want to try and improve your understanding using strategies such as concept maps or Freya models. Let's now have a look at charge. Considering some of the particles we've just mentioned, it's important to know that protons have a positive charge and electrons have a negative charge. Given that atoms and molecules contain an equal number of protons and electrons, they are neutral and have no charge. And when atoms and molecules lose or gain electrons, they become ions which can be positively or negatively charged. Once we have a good understanding of charge, we'll be able to consider how particles interact with each other through electrostatic forces. Remember, when we're talking about electrostatic forces, we're talking about either attractive or repulsive forces, depending on the charge of the particles in the system. For example, if we have 2 nuclei that contain protons near each other, they will repel each other. In the same way, if I have negatively charged electrons near each other, they will also repel. And because protons and electrons have opposite charges, they will attract one another. One of the key ideas in this topic is electronegativity, and this is the ability of an atom to attract valence electrons. A good understanding of this will help us predict the type of bonding we might expect to find in a substance. This unit also visits the idea of intermolecular forces. And again, this ties to our core concept because they are actually weak electrostatic forces of attraction between covalent molecules. A good understanding of the different types of intermolecular force will help us accurately predict some physical properties of these substances. In order to fully understand ionic bonding, we need to know that oppositely charged ions will attract each other and ions of the same charge will repel each other. And this is why ionic compounds tend to form 3D lattices. Finally, and perhaps one of the more complex core concepts, is potential energy. As a quick reminder, potential energy is related to the position of charged particles. A low potential energy state, or a stable state, will occur when oppositely charged particles are close to each other, or similarly charged particles are far apart. These are favourable arrangements of those particles. So in relation to bonding and structure, there are a number of understandings related to potential energy. As mentioned before, oppositely charged ions will arrange themselves in a 3D ionic lattice to minimise repulsion and maximise attraction between like and oppositely charged ions. In a covalent bond, atoms will position themselves to maximise attraction between nuclei and a shared pair of electrons, but also to minimise repulsion between the 2 nuclei themselves. In metallic substances, the lattice of positive ions and delocalised electrons reaches its lowest potential energy state when those positive ions are in a regular arrangement and surrounded by delocalised electrons. And finally, when considering intermolecular forces, a low potential energy state or stable state is achieved when molecules are close to each other, which is why to change a state of matter from a solid into a liquid, maybe even a gas, I need an input of thermal energy from the surroundings in order to increase the potential energy of my system. And that's it for now. As a bit of conceptual practice, you might want to use your own knowledge or maybe even look at the syllabus and see if you can tie individual syllabus points to these 4 core concepts. Hopefully, this video is of some help.